So guys, in our previous video, we saw the two classifications of your colloids. So one classification was based on the physical states of your dispersed phase and the dispersion medium. And the second classification was based on the what type of your interaction exists between that of your dispersed phase and the dispersed medium. Today we are going to see a last but the latest one more classification of your colloids. So this classification is mainly based on, do remember, this classification is mainly based on the we can say what? The type, based on the type of particles, based on the type of the particles of dispersed phase. So mainly we are dealing with the classification which is depending upon the type of the particles of your dispersed phase. Basically this classification is once again has been subdivided into three types depending upon the type of your particles. So first is the most important thing, which itself is called as what? Multi-molecular colloids. Multi-molecular colloids. The second one is called as macro. What it is? Macromolecular colloids. Macromolecular colloids. Last one is called as an associated colloids. Associated colloids, or it is also called as micelle. It's also called as micelle. So first and the foremost thing, before going to this classification, once again I want to remind you about the main concept of your colloids. As I have said, your colloid is an heterogeneous system in which the dispersed phase particles are being in a continuous random motion in your dispersion medium. Mark my words, your dispersed phase particles are in the continuous random motion. If for example, this is your colloidal system. ಇದರಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಉಂಟು ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ರಿಮೆಂಬರ್, ನಿಮ್ಮ ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, ದೇ ಆರ್ ನಾಟ್ ಸೆಟ್ಲಿಂಗ್ ಡೌನ್, ಆರ್ ದಿ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ನಾಟ್ settling down. Instead, how they are doing, they are in the continuous random motion within that system. ಇದೇ ರೀತಿಗೋಸ್ಕರನೇ we are distinguishing your colloid with that of your suspension. Suspension ಏನಾಗುತ್ತೆ, ಸ್ಯಾಂಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಹಾಕಿದ ಕೂಡಲೇ ಕೆಳಗಡೆ ಬಂದು ಎಂಬೆಡ್ ಆಗ್ಬಿಡುತ್ತಲ್ವಾ. ಆದ್ರೆ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆತರ ಎಂಬೆಡೆಡ್ ಆಗೋದಿಲ್ಲ. ಆ ರೀಸನ್ ನ ಕೂಡ ನಾವು ನೋಡ್ತೀವಿ, ಒಂದು ಪ್ರಾಪರ್ಟಿ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಬ್ರೌನಿಯನ್ ಮೂವ್ಮೆಂಟ್. ಅಲ್ಲಿ ನಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ ಯಾಕದು ಓಡಾಡ್ತಾನೆ ಇರುತ್ತೆ. ವಾಟ್ ಇಸ್ ದ ರೀಸನ್ ಫಾರ್ ದಿ ರ್ಯಾಂಡಮ್ ಮೋಷನ್, ದ zigzag motion of your colloidal particles. But just for a while, you just keep in your mind that whenever we are dealing with the colloidal system, you should remember that the dispersed phase particles are in the continuous random motion. They are not coming together and forms a precipitate. Oh, precipitate agodilla. Okay, so what you have to remember, your dispersed phase particles are in the continuous random motion. Now let us go with our concept of your classification. So first is called as what? Multi-molecular colloids. Hagare artha enu? Now whatever we are going to read over here, it depends upon how the colloids are formed in all these three cases. Okay, namgen gottu what? Whenever we are seeing the colloidal particles, what is their dimensions? Yes, it is ranging in between 1 nanometer to that of your 1000 nanometer. And what do we know? There are also certain particles in which it could be less than also 1 nanometer anta nodidivi. E multi-molecular colloids is taking an advantage of those molecules. Yenagta unte multi-molecular colloids alli andre, remember here large number of atoms, mark my words, large atoms alla, what it is saying, large number of atoms or smaller molecules are aggregating each other or are aggregating together together to form species of colloidal range ಅಂತ ಹೇಳುತ್ತೆ. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ಈಗ ಇದನ್ನ. ನಾವು ವಿಲ್ ಬಿ ಗೋಯಿಂಗ್ ಒನ್ ಬೈ ಒನ್. ಮಲ್ಟಿ ಅಂದ್ರೆ ಏನು? ಮೆನಿ. ಮಾಲಿಕ್ಯುಲರ್ ಅಂದ್ರೆ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ಸೊ ಏನಾಗ್ತಾ ಉಂಟು, ಅಫ್ಕೋರ್ಸ್ ನೀವು ಕೆಲವೊಂದು ಸಿಸ್ಟಮ್ ನ ತಗೊಂಡಾಗ ನೀವು ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀರಾ, ಸರ್ಟನ್ ಥಿಂಗ್ಸ್ ನ ಆಡ್ ಮಾಡ್ತೀರಾ. ಆ ಆಡ್ ಮಾಡಿರೋ ಸಬ್ಸ್ಟೆನ್ಸ್ ಕೊಲಾಯ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಗಿ ಇರೋದಿಲ್ಲ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಕೆಲ ಸಿಸ್ಟಮ್ ಅಲ್ಲ ಸಾಮರ್ಥ್ಯ ಯಾವ ತರ ಇರುತ್ತೆ ಅಂದ್ರೆ, ಆ ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಿರುತ್ತಲ್ಲ, ಅಫ್ಕೋರ್ಸ್ ಅದ್ರದ್ದು ಡೈಮೆನ್ಷನ್ ಏನಾಗಿರುತ್ತೆ, 1 ನ್ಯಾನೋಮೀಟರ್ ಗಿಂತನೂ ಕಮ್ಮಿ ಇರುತ್ತೆ. ಇಟ್ ವಿಲ್ ಬಿ ಲೆಸ್ ದ್ಯಾನ್ 1 ನ್ಯಾನೋಮೀಟರ್. ಸೊ ದೀಸ್ ಟೈನಿ ಮಾಲಿಕ್ಯೂಲ್ಸ್ whenever it is present in a system, they will try to come together. ಟುಗೆದರ್ ಬಂದಾಗ ಏನಾಗುತ್ತೆ, ದೇ ವಿಲ್ ಫಾರ್ಮ್ ಅನ್ ಅಗ್ರಿಗೇಟ್. ಅಗ್ರಿಗೇಟ್ ಅಂದ್ರೆ ಏನು? ಒಗ್ಗೂಡೋದು. ಒಗ್ಗೂಡು ಏನಾಗುತ್ತೆ, ದೇ ವಿಲ್ ಫಾರ್ಮ್ ಅ ಸ್ಪೀಶೀಸ್. ಇವೆಲ್ಲ ಏನಾಗುತ್ತೆ, ಅಗ್ರಿಗೇಟ್ ಆಗಿ ಒಂದು ದೊಡ್ಡ ಸ್ಪೀಶೀಸ್ ಕೊಡುತ್ತೆ. ಈ ಸ್ಪೀಶೀಸಿನ ರೇಂಜ್ ಏನಾಗಿರುತ್ತೆ, 1 ನ್ಯಾನೋಮೀಟರ್ ಟು 1000 ನ್ಯಾನೋಮೀಟರ್. ಸೊ ಸಚ್ ಕೊಲಾಯ್ಡ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಮಲ್ಟಿಮಾಲಿಕ್ಯುಲರ್ ಕೊಲಾಯ್ಡ್ಸ್. ಸೊ ಸರ್ಟನ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ನಾವು ಡಿಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಆ ಆಟಮ್ಸ್ ಏನಿರುತ್ತೆ, ದೇ ವಿಲ್ ಬಿ ವೆರಿ ಸ್ಮಾಲ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಸಚ್ ಲಾರ್ಜ್ ನಂಬರ್ ಆ ಆಟಮ್ಸ್ ಏನಾಗುತ್ತೆ, ಒಟ್ಟಾಗುತ್ತೆ. ಅಥವಾ ಏನಾಗುತ್ತೆ, ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇದ್ರೆ ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಎಲ್ಲ ಏನಾಗುತ್ತೆ, ಅಗ್ರಿಗೇಟ್ ಆಗುತ್ತೆ. ಅಗ್ರಿಗೇಟ್ ಆಗಿ ಏನ್ ಕೊಡುತ್ತೆ, ಆ ಸ್ಪೀಶೀಸ್ ವಿಲ್ ಬಿ ಗಿವನ್ ವಿಚ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಆಫ್ ಎ colloidal range. Very much important. So such colloids are called as what? Multimolecular colloids. So let us have certain examples for your multimolecular colloids. So there are your sulfur salt or that of your gold salt. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು, whenever we are taking the sulfur salt as an example for the colloids, it should come to in your mind that this sulfur atoms initially what they will be of very smaller dimensions, but what happens, these smaller atoms will try to aggregate or they try to come together and they will be forming as a species which will be having the colloidal dimensions. So that is the reason we are taking the sulfur salt or that of your gold salt as the example for your multimolecular colloids. Coming to the next part, which is called as what? Macromolecular colloids. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಹೆಸರಲ್ಲೇ ಹೇಳ್ತಾ ಉಂಟು what it is, macro. The molecule itself is big enough, alwa. The molecule itself is big enough. So that molecule, when it is dissolved in a suitable solvent, alwa. So the macromolecules, if I am going to take this macromolecules in a suitable solvent, when it is taken in a suitable solvent, what happens? It forms a solution, alva. It forms a solution. ಈ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಈಗ ನಾವು ನೋಡಿದಾಗ ಏನಾಗಿರುತ್ತೆ, the size of your macromolecules will be in the colloidal range. ಏನ್ ಹೇಳುತ್ತೆ ಅದು? The size of the macromolecules will be in colloidal range. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? Whenever you are choosing a macromolecules, ಆ macromolecules ನಾನು ಒಂದು ಸೂಟೇಬಲ್ ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲಿ ತಗೊಂಡು ಸೊಲ್ಯೂಷನ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ದೆ ಅಂದ್ರೆ, ಆ ಸೊಲ್ಯೂಷನ್ ಇರೋ ಸೈಜ್ ನ ಡಿಟರ್ಮೈನ್ ಮಾಡಿದೆ ಆ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಂದು. ಸೊ ಆ ಸಿಂಗಲ್ ಮಾಲಿಕ್ಯೂಲಿನ ಡೈಮೆನ್ಷನ್ ಏನಾಗಿರುತ್ತೆ, ಕೊಲಾಯ್ಡಲ್ ರೇಂಜ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ದ ರೀಸನ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ as what? Macromolecular. Single molecule itself is having the capacity or the particle size range of your 1 nanometer to 1000 nanometer. But what happened in multimolecular, of course the molecules were having the smaller shape. So these molecules, when they are trying to aggregate, they are forming of your colloidal range. Let us see now the examples of your macromolecular colloids. So basically everyone will be having a doubt that such colloids, whether it is existing in our body, alwa. So by the example itself we'll come to know whether colloids exist in our body or not. So basically when I'm going with the example, let me take the examples in two cases. One is a natural macromolecular colloids, and the second one is called as an artificial macromolecular colloids, or we can also say it as a man-made. To be more specific, we can say it as a man-made macromolecular colloids. So when we are seeing this natural macromolecular colloids, we are having the examples as that of your starch, your cellulose, the proteins, the enzymes. So basically these are the things which are present in our body. Of course, when we are seeing a structure, it's a bulk structure. But when we are considering its monomeric unit, a smaller unit part, of course, those will be having the range of 1 nanometer to 1000 nanometer. Since these are all extracted or they are all present in our body, this is a nature gift. It is called as what? Natural macromolecules. Single molecule itself is having the dimensions of your 1 nanometer to 1000 nanometer. Coming with respect to the man-made your macromolecular, of course, the common example is that of your polythene. Whatever the polythene bags we are using, polythene, polyethene anta. So the polythene or the nylon or the polystyrene. So these are certain examples which is coming under the man-made macromolecular colloids. So what is the main difference when you are considering with respect to multimolecular and a macromolecular? In multimolecular, the substances, when they have been taken or when they have been dissolved in a suitable solvent, the smaller atoms or the smaller molecules are aggregated to form a species which will be having the dimensions of your colloidal range, that is of 1 nanometer to 1000 nanometer. But when we are coming with respect to the macromolecular colloids, remember that these substances, when they are dissolved in a suitable solvent and they are forming a solution, when we are measuring the size of these macromolecules, the single molecule itself will be having the dimensions of your colloidal range. Of course, the suitable examples also we have seen. In multimolecular, we are having the sulfur salt, your gold salt. Whereas in a macromolecular, once again, we have been split into two types: natural macromolecular colloids and a man-made macromolecular colloids. Natural macromolecule may you are having your starch, cellulose, proteins, enzymes. Basically that single molecule itself will be having the dimensions of your colloidal range. Similarly, with that of your man-made also, we are having polythene, nylon, polystyrene, in which a single molecule itself will be having the dimensions of your colloidal range. Most important thing, and another type you are going to see, which is called as what? Associated colloids. Associated colloids. By the name itself, you can judge what it wants to say. But do remember, it is having a slight resemblance with respect to that of your multimolecular. Mark my words, a slight resemblance. Let us see how is it. So you have to understand about this associated colloids in such a way that, so these are the substances. Do remember, at low concentration, they act as strong electrolyte. Okay, but at a high concentration, what they do, they exhibit a colloidal behavior. How they will exhibit? By the formation of aggregates. This is the major important thing of your associated colloids. As I said, it is having a slight resemblance because it is forming an aggregate, as that we have studied with respect to the multimolecular. But what is the main difference between multimolecular and that of your associated colloid? Whatever may be the concentration of your multimolecular colloids, it will not act as an electrolyte. But whereas when you are coming with respect to the associated colloid, do remember that at a lower concentration, mark my words, at a lower concentration, they act as a strong electrolyte. Whereas at a high concentration, that is, as the concentration you are going to increase, they form an aggregate and they behave as that of your colloidal particles. That is the main thing. As I mentioned, this associated colloids is also called as what? Your mycenae. Very much important concept, because by using this concept we are going to study that how does your soaps or detergents basically are helpful to remove the dirt from your clothes. Okay, so before going to that part, I want to make you two things clear. So when we were dealing with these associated colloids, we came to know that there is a specific concentration, alva. At some specific concentration, our associated colloid is acting as a colloid, alva, below which it will be acting as an electrolyte, strong electrolyte. Once again, I am mentioning strong electrolyte. So we came to know that what? There is one specific concentration. And of course, in this associated colloids, we are also having one particular temperature also. So how can we define this temperature and concentration with respect to the associated colloids? Let us see first. First and the foremost thing, you just remember the temperature above which formation of your mycenae takes place. Formation of mycenae takes place. Mycenae andre artha enu? The molecules are coming together. They are forming an aggregation. Oggudta untala. A temperature at that temperature above which such mycenae formation takes place. Okay. Formation of the mycenae takes place. That is called as, basically we are using a new word for the temperature. That is called as Kraft temperature. K-R-A-F-T. It is not C, it is K. K-R-A-F-T temperature. Kraft temperature. Important definition. So what do you mean by Kraft temperature? The temperature above which formation of the mycenae takes place. So that is called as what? Kraft temperature. Of course, we have dealt now with temperature. Then what to say about this concentration? Do remember, the concentration above which formation of the mycenae takes place. Formation of your mycenae takes place, remember. So that is called as critical mycenae concentration. What it is called as? Critical mycenae concentration. Simple words, we can also use it as CMC. Yes. So what is called as critical mycenae concentration? The concentration above which formation of your mycenae. Mycenae, and once again I am repeating, all the molecules are coming together to behave as that of your colloidal particles. So ಆ ಒಂದು concentration ಅಲ್ಲಿ ಎಲ್ಲಿ ಆತರ mycenae form ಆಗುತ್ತೋ, that is called as what? Critical mycenae concentration. And the temperature at which such mycenae is also taking place, that is also called as Kraft temperature. So utilizing the definition of your associated colloid and that of your Kraft temperature and this critical mycenae concentration, we are going to first see how this mycenae takes place by using the soap as an example. Once again I am repeating, now we are going to see how does the mycenae forms. Alva, how does your mycenae forms by taking soap as your example. Okay. So now, first of all, we have to understand what do you mean by a soap? How can you define it? Alva, do remember your soap is a sodium or potassium. It is a sodium or a potassium salt. Salt and it is an ionic content anta. Okay, please do remember a cation irutte and anion irutte. Sodium or a potassium salt of higher fatty acids. So general representation or representation on the soap na represent maadi general agi andre basically just remember we will be writing it as RCOO minus Na plus irbodu athwa K plus irbodu. That is the reason I have said sodium or potassium, but this part will be same, salt of higher fatty acid. Is that clear? Generally we will be taking the soaps, whatever the bar soaps we are using, they will be having the formula. I'm just writing the value for this R. What is this general R? It is actually CH3 CH2 16 times. This is your higher fatty acids. Okay, COO minus Na plus. General general R ಅಂತ ತಗೊಂಡಿದೆ. ಆ R ಏನಾಗಿರಬಹುದು ಅಂತಾನು ನಾವು ನೋಡಿದ್ದೀವಿ. That is what CH3 CH2 16 times CO minus Na plus. So sodium or potassium salt of your higher fatty acids. So this one overall is your fatty acid. Is that clear? Now the question arises, of course, whatever the soap we are using, it is having this combination. But as soon as you're taking this soap or it comes in a contact with water, of course what will happen? Na plus and that of your anion part will get split off. Alva. So when it is dissolved in water, how it is going to dissolve? I'm taking my general example. RCOO minus plus Na plus. Alva. This is the major thing. Whatever the soap action we are seeing, it is mainly responsible by this anionic part. So now whatever we are going to study about the cleansing action of the soap or the formation of the micellae, overall it depends upon this part, RCOO minus part. Very much interesting. So when we are seeing this RCOO minus, it is having a two parts, if you can just see. Alva. First, one is your R group and another your COO minus group. So what is this R actually? As we have seen, it is CH3 CH2 16 general. Alva. So this is a long hydrocarbon chain. Alva. Long hydrocarbon chain. Long hydrocarbon chain, and it is also non-polar. It is what? Non-polar. Alva. RCO minus Ali. Whatever this is, R is there, that is what? Non-polar. And it is also, you should remember, it is an hydrophobic part. What it is? It is an hydrophobic. This R part, whatever we are seeing, it is water hating part. It is a non-polar because it doesn't carry any charge, and it is what? A long hydrocarbon chain which is non-polar, and it is hydrophobic. Hydro means water, phobic means hating. Water hating. So these terms you should remember. Coming with respect to your COO minus, do remember. So this is actually polar ionic head. I will say why we are calling it as a head and this part as that of your tail. But for a while you just remember polar ionic head is which one? Your COO minus part. So of course what it is? It is hydrophilic. Do remember, it is your hydrophilic. This COO minus part is what? Water loving part. Is that clear? Now let me write you how we are going to write this structure. So basically here we are having your CH3, alva, CH2, 1C, another C, 1C, another C. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, how much? 11, 12, 13, 14, 15, 16. Alva. So 1, CH3 is there, yes. Each intersection, whatever we are seeing, it is all representing your carbon atoms. So CH2 is how much? 16 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then afterwards, once again, we are having this COO minus group. Alva. So let me take it as what? Like this. A circle part. So we can just see over here. What is that? So whatever the CH3, CH2 16 part is there till here. Alva. So this is called as what? As a tail. A non-polar hydrophobic tail. Alva. This is what? Hydrophobic tail. Remember, it is an action of your soap. Soap and this structure should come in your mind. So this is your hydrophobic tail. So whatever we circle we have written over here, remember, this is actually your hydrophilic head anta ಹೇಳ್ತೀವಿ. Hydrophilic head. That is the reason we have seen over here polar ionic head, since this is what your COO minus group. So this circle is representing what? it is having a negative sign. It is what? Hydrophilic, a polar group. Whereas the part CH3, CH2 16 times, it is representing what? Your hydrophobic part, a non-polar group. So this is the structure, general representation of your soaps when it is dissolved in water. Once again I am repeating, when it is dissolved in water. Is that okay? Now the question arises, what is happening when you are coming, that is whenever your soap is in the contact with the water. So remember, whatever this RCOO minus we are seeing overall this part, it always remains at the surface of the water. Alva, ನಾವು ನೋಡಿದೀವಿ, ನೀವು ಎಲ್ಲರೂ ನಿಮ್ಮ detergents na ಹಾಕ್ತೀರಾ bucket ಒಳಗೆ and you are stirring it, whatever the froth will be formed, it is mainly on the surface. Alva, this overall RCOO minus ions are present on the surface. Now the question arises that how they are present. Alva, do remember, if I consider this one as my tub and this is your surface of your water. The upper part is your surface of your water. What we have come to know, the head part is an hydrophilic. That means it is water loving. Whereas that of your tail part is what? Hydrophobic, water hating. So below, I am talking about below CMC. Till now I have not come to my critical micellar concentration. Below critical micellar concentration, the molecules of your soap is in this way. So of course the hydrophilic head, alva, this is the head which is water loving. It will be present inside the water. Alva, since it is water loving, it is interacting with the water. But the hydrophobic part, what it will do, it is away from that of your water. Away from that of your water. So this is your hydrophobic part which is away from the water, whereas this is your hydrophilic part which is inside the water. And do remember, it is below CMC. That is at the time when they are acting as a electrolyte, strong electrolyte, and lower concentration alli enagirutte nimma soap molecules ee tara arrange agirutte. Now the question arises, how does the micellar forms at CMC? That is at critical micellar concentration, how the micellar will be formed. Do remember, as soon as you are coming to the concentration of your critical micellar, what happens? These molecules, whatever we are seeing, these anions are pulled inside. Enagutte? They are pulled inside into the bulk of a solution. They were in the surface part. So concentration jasti adkulu enagbidutte. Now they will be pulled inside the solution. So how they will pull? Now this is your beaker andre. So they will be forming. So this is your water. Now these ions have been pulled inside in such a way that they form a sphere. They form a sphere inside this solution such that all your hydrophobic part enirutte, they will be present or they will be pointing towards the center of this sphere, whereas that of your ionic head, what is present, that will be present on the surface of that sphere. So this is called as your micellar formation. So this is called as what? Your micellar. So ಏನಾಗ್ತಾ ಉಂಟು, at CMC, that is your critical micellar concentration, the anions are pulled into the bulk of the solution. Okay, and they aggregate to form a spherical shape. Alva, as you can see, with their hydrocarbon chains. Alva, this is your R group, hydrocarbon chain pointing towards the center of the sphere. Okay, and that of your COO minus group, alva, the head part, that is remaining outside the surface of the sphere. So this way your micellar will be formed. So this is the formation of your micellar when at critical micellar concentration. Okay, so an aggregate thus formed, so this is called as what? Ionic micellar. So each micellar, remember, each micellar can contain such 100 ions. ಈ ತರ ಒಂದೊಂದೇ ಪಾರ್ಟ್, ಒಂದು micellar ಏನಾಗಿರ್ಬೋದು, ಕನಿಷ್ಠ ಅಂದ್ರೂ ಕೂಡ ಈ ತರ 1, 2, 3 like this 100 ions can be present. Is that okay? So this is the formation of your mycelium. Now taking this mechanism, we are going to understand what your cleansing action of soap. We are going to understand what? The cleansing action of soap. Okay. Of course, when you are using soap to your clothes, whenever it becomes dirty. How does it becomes dirty? Of course, whatever the sweat which is being excreted out from our skin glands, that will be coming in contact with that of your atmospheric dust particles, and of course our clothes becomes dirty. This is the general criteria. Whenever your clothes become dirty, when you're matured, of course you're not playing in the mud. In that case I'm talking about. But do remember, whatever the soap molecules are there, they are going to form a mycelium around the oil droplet. How they are going to form? Let us see. So I will consider this one is your surface of your cloth. Okay. We are seeing in a microscopic view, just understand in that way. So on this surface, let us say this is your dirt part. Because dirt is not the part which is been with that of your cloth. So it has been stuck. So I am showing it what? In a bulged manner. So what happens? Yeah. So as soon as you are using certain soaps or detergents, do remember they are going to form this mycelium at this oil droplets. How they will be forming? Let us see. As we have said, this will be your ionic head in this way, whereas the hydrophobic end will be in this way. So let us consider now you are taken in a tub of water. This is your clothes and you have been filled with that of your water. Water na hakidira, clothes na hakidira, detergent no hakidira. Detergent concentration at CMC reach agide. ಏನಾಯ್ತು ಈಗ CMC ಲಿ ನಿಮ್ಮ ions ಬಂದು ಏನಾಯ್ತು aggregate ಮಾಡ್ಬಿಡ್ತು. Okay, it is being formed a mycelium. Okay, so what we know, we are seeing that whatever the hydrophobic part is there, it is inside that oil droplet, whereas what your ionic head, what is there, that is present on the surface. That is the major thing you have to understand over here. Now we have to understand what happens since it is a hydrophilic groups. Whatever the formed mycelium we are seeing, the hydrophilic groups are pointing towards the water. So they are water loving also. So what happens? These hydrophilic groups try to move towards the water. But when they try to move towards the water, what they do? They will not go alone. They will not go alone. Along with them, they will also take the dirt with them. So by this way, what happens? Dirt goes along with that of your mycelium and your clothes become dirt free. This is the major cleansing action of your soap. Once again I am saying, so you have to cut up of water and to that one you have put your clothes which is having a dirt and you have put a detergent to it. So what is happening as soon as you put the detergent, a specific concentration when you reach, that is your critical mycelium concentration, whatever your detergents has been there used, so they are forming a mycelium around the oil droplet or that of your dirt because it's like a grease part itself. So on the mycelium nodaga, now what we are seeing, whatever the polar group is present, they are projecting towards the water, whereas the hydrophobic part which is present, they are projecting towards the oil drop. And we know what? Since our hydrophilic group is water loving, of course they will try to interact with the water. So when such interaction is developed with the water, this anions will also pull the oil along with it or the dirt along with it. So when the dirt also moves with it, what happens? Your clothes become dirt free. So this is actually the cleansing action of the soap. So that is the reason, in order to understand the cleansing action of the soap, first and the foremost thing you have to understand that how this mycelium is formed. And when this mycelium is formed, you have to understand what is the structure specification of your mycelium. That is, your hydrophilic group will be at the surface, whereas that of your hydrophobic group will be pointing towards the center of the sphere. Is that cool? Yeah. So by this way, your soap helps in washing away the oils and that of your fats from your clothes. Okay. Yes. So in our next video, we are going to see the preparation of your colloids. Very much important thing. Basically, we are going to see one is a chemical method and another is that of your Bredig arcs method. That is your preparation of your goldstone. Both is important. Okay. So just for today, we have seen the classification of your colloids, which is based upon the particles of your dispersed phase. We saw in there multimolecular colloids. Macromolecular colloids are the associated colloids, or it is also called as mycelium. And majorly we saw in multimolecular colloids what is happening. The smaller molecules are coming together and they form a species which is having the dimensions of your colloidal range. In a macromolecular colloids, what did we see? These substances, when they are dissolved in certain suitable solvent, they form a solution, and the size of the macromolecules which will be available, they will be having the dimensions of your colloidal range. Whereas in that of your associated colloids, at low concentration, they act as what? Strong electrolyte. Why they are acting as a strong electrolyte? We can easily explain. Why? Because they are the charged species. You can just see whatever the soap you have taken is actually a salt. So they can act as what? As an ionic. They can act as an electrolyte. So at low concentration, they act as a strong electrolyte. Whereas as the concentration increases, of course, they are going to aggregate and they behave as that of your colloidal particles. And the major important thing we came to know that whenever the aggregation is taking place, that is called as what? Mycelium. And for the formation of a mycelium, a particular temperature has to be maintained, which is called as that of your Kraft temperature, and also a particular concentration is required, which is called as a critical mycelium concentration. So we came to know the next important part, that is the action of soap. That our soap, whenever you're considering, it is actually a sodium or a potassium salt of your higher fatty acids. Generally, when they dissolved in water, you're going to get a cation and an anion. The major cleansing action of the soap is almost dependent upon the anionic part of your soap. And that anionic part consists of two parts. That is, one is a long hydrocarbon chain, which is a non-polar and a hydrophobic group. And another is an anionic group, which is a polar ionic head, which is hydrophilic. That is your water loving. So what happens at CMC basically? Okay, below CMC, first you have to remember how they are present. They are only present at the surface in such a way that whatever your polar head is there, that will be inside the water, and that of your non-polar group will be away from the water. This is when below CMC. So at CMC, that is your critical mycelium concentration, what happens? These anions will be pulled inside. They are trying to pull inside into the bulk of the solution. And when they are coming inside, what they are forming? A mycelium will be formed. What is this mycelium actually? It is like a spear, such a way that the polar head will be at the surface of the spear, whereas the non-polar group will be pointing at the center of the spear. Is that clear? And each mycelium can almost has 100 such anions. Do remember. Okay. Then getting the concept of this mycelium, we saw that how these soaps are used in the cleansing action. So basically we know that whenever we sweat, that will be coming in contact with that of your clothes, and that is going to get absorbed with that of your dust particles present in the air. So if I consider this part as that of your cloth and the bulged part as that of your oil droplet, that is your dirt. So when you put certain detergents, what happens? The mycelium will be formed around this dirt, the oil droplet, in such a way that the polar group will be present on the surface of the dirt, whereas that of your hydrophobic part will be projecting at the inside of the dirt. We know what this hydrophilic part is, water loving. Hydrophilic part, this hydrophilic part is water loving part. So it will try to interact with the water, this polar head part. So when such interaction develops, what happens? They move towards the water. Along with them, they also take the dirt with them. So that by that way, what happens? Your clothes become dirt free. And that is the reason why we say that your soaps are used for washing purpose. Is that clear? Okay. Yeah, many times, certain times they have also asked for a given example of a soap So I would like to give an example of a soap. General example, we call it as a sodium lauryl sulfate. Sodium lauryl sulfate. Just take its formula CH3 CH211 SO4 minus and it of your Na plus. Of course, what we have seen, this is also an example of a soap, but major times they can ask you to write the formula for sodium lauryl sulfate. This is also an example of a soap. Do remember it is CH3 CH211 SO4 minus Na plus. The same part, sodium or a potassium salt of your higher fatty acids. This now when it dissolves, what happens? This CH3 CH211 part will be what? Your hydrophobic part. Whereas that of your SO4 minus will be what? Your hydrophilic part. Whatever the cations will be, that will split off. That will not be of use for us when we are doing with that of your in water when they get dissolved. Whatever the main mechanism of your cleansing action of soap is there, that only depends upon this anionic part. Only about this that we have seen also. Okay.